Welcome dear students. In the last video we have discussed about LCM, that was lowest common multiple, and the smallest number that is divisible by both the given numbers. In today's lecture we are going to discuss HCF. HCF is highest common factor, that is the largest number that divides both the given numbers. Those students who are new to this video, if they want to have a video about LCM, you can go back to the playlist and check the videos over there. Now HCF, so we'll say, we'll first of all give a difference between HCF and LCM, then we'll start with the HCF. Now let's say HCF of 4 and 12 will be 4, as 4 is the largest number that divides 4 and 12 both. Right? It can also be 1 and 2, because 1 also divides 4 and 12, 2 also divides 4 and 12, and 4 also divides 4 and 12. But the largest value among those is 4. Hence, while choosing the HCF, we will be dealing about the largest number. However, if LCM was supposed to be found out between 4 and 12, so we would say a number that is divisible by both the numbers, the answer would have been 12. So 12 is divisible by 12 and 12 is also divisible by 4. This is just to cast a brief difference between what the LCM and what the HCF is. However, we will study HCF in a detailed manner now. Now, HCF means highest common factor, that is a number or the largest number that divides both the given numbers. Right? How are you going to find the HCF? So HCF is found out by two methods. One is prime factorization and the other is long division, or that is Euclid's division algorithm. Right. We'll discuss them step by step. First of all, we'll discuss it by prime factorization. So let's take an example, 30 and 36. Now again, whenever you are supposed to ask the HCF or LCM, the first step is same, that is you will take the prime factorization over there. This is 2, 15, this is 3, 5, this is 5 and this is 1. Over there this will be 2, this will be 18, this is 2, this is 9, this is 3, this is 3 and this is 3 and this is 1. Right. Now again we will list down the prime factors over there, 2, 3, 5, 2 square and 3 square. Right. Now since we are finding the HCF, so in HCF we will choose the lowest powers among the common terms, and only common terms are to be considered. Uncommon terms we are not going to select those things. So the prime factorization over there yields to 2, 3 and 5, and over here it is 2 square into 3 square. So now let's see, HCF should be 2 is common to both of them, and 3 square and 3 will choose the smallest one, that is 3. So the HCF should be 6. Now 6 should be the largest value that divides both of these things. So yes, we can say that 30 divided by 6, this is 5, and 36 divided by 6, this is 6. However, they are also divisible by 1, they are also divisible by 2, and they are also divisible by 3. But the largest value among them is 6. So hence the HCF comes out to be 6. By this you can verify your answers in the examination, where you don't have to look at the back of the exercise to find the answers. Now if you want to have a screenshot, I'll give you some time and you can put it on screenshot. Then we'll proceed with the next example. This example is a crucial one. Please pay attention to this one, because the same example we are going to put when we will be doing the long division method, so that you can verify that whatever the method we use, the answer remains the same. 135 and 225. Now 3, this will be 4, 5, 45, 3, 15, 3, 5 and 5, that is 1. Now over here again 3, 7, 5, 3, 25, 5, 5 and 1. So the factors will be 3 cube into 5 and 3 square into 5 square. Now in HCF we will take the common powers, and that will be the least value. 3 cube and 3 square, the least value is 3 square. 5 and 5 square, the least value is 5. Hence the HCF should be 9 into 5, that is 45. So they both will be divisible by 3, they both are divisible by 5, and the largest value among them is 45. Now let's take one more example. 9 and 10. Now this is, we know that this is 3, 3 and 1, that is 3 square, and this is 2 into 5. Now in this case, when none of the factors are common, so then you can directly write the number 1. So this is very important for you to know. If none of the factors are common to them, the HCF is 1. Hence we can also write HCF of 2 consecutive prime numbers, or it can be any numbers, any prime numbers. The HCF is always 1. Right. Now with this we can again rewrite the properties of HCF. So whenever you are supposed to find the HCF, how you are going to check in the examination whether the answer that you have found out is correct or not? First of all, HCF can never be greater than the given values. HCF should always be less than or equal to the given values. So we'll say how it is less than. Again you can say the HCF of 4 and 5 will be 1, and 1 is smallest than both the given numbers. HCF of 9 and 27 will be 9 itself, because this is the largest number that divides both the given numbers. So hence you can say that this will be the case where it is equal to, and it can never be greater than the given numbers. Right. And one more important thing, that HCF is a factor of LCM, because this is a very important question in competitive examinations. So HCF should always be the factor of LCM. If HCF is not a factor of LCM, then you won't say that that particular thing will be the LCM or LCM of that thing. Right. So in this video we'll terminate it only up to the prime factorization, so that you practice these questions and get an idea how to get the prime factorization done. In the next video we will discuss about the long division algorithm. Thank you.